All right, welcome back, my friends. We are going to do now an example together from page 347. It's example 6-13. So we have this company that reports that a polling company that reports that children between the ages of 2 and 5 watch an average of 25 hours of television per week. We're assuming that the variable is normally distributed and that the standard deviation is 3 hours. Now we're taking an n of 20, which is less than 30, so we can't really employ the central limit theorem, but they told us that the parent distribution is normal, so no worries there. So let's write down what we know about this parent distribution. We know that the mean is 25 hours per week. We know that the standard deviation is 3 hours per week. Now they tell us that they're taking samples of 20 children between the ages 2 and 5, and they are selected randomly. So there we go. And they're asking us what is going to be the probability that the mean number of hours that they spend watching TV is going to be greater than 26.3 hours. Well, so we are not talking about population distribution. We are talking here about a sampling distribution. The sampling distribution has n equals 20. Well, if it's a sampling distribution, then remember the standard error of this is going to be much narrower than the actual standard deviation of the population. So let's write down the things that we will know about the sampling distribution. So the mean of all the means of all the samples of 20 is going to be, drum roll, 25 hours per week. And this is going to be the same because that's the whole point of taking these repeated samples in order to estimate our mean, and this is our parameter, and this is an unbiased estimator. Let me know if you don't remember what's an unbiased estimator. Now, if I would like to figure out the standard error of all those samples of 20, I would have to take simply my standard deviation of the population, and I am going to divide it by the square root of the sample size. Okay, and if you're going to take out your calculators and calculate this, I ended up with 0.671. And I always encourage you guys to pause the video and calculate things on your own and make sure that you're ending up with the same things that I end up here in these videos. If I make mistakes, let me know. I'll fix them up. Alrighty, so now I'd like to know what is the probability of these samples watching TV more than 26.3 hours? Well, I'd like to draw and I'd like to shade, and you know that we've done that a lot and you're pretty good at that. Not the best standard normal distribution here, but we know it's centered at 25 hours. And I'd like to know, where am I putting this 26.3? Am I putting it right here? Am I putting it right here? Am I putting it in the middle? I'd like to know where to put that. So how do we know? That's right, guys. We're going to calculate our z-score. And our z-score is simply the value that they give us, 26.3 minus 25. Divide by that standard error, 0.671. And we will have to round that, ladies and gentlemen. So we are going to round that to 2 places after the decimal so we can use the z-chart. So 1.94. So where am I putting it? 1, 2, 3. I'm going to put it a little bit before 2 standard deviations. Right? I'm putting it right here. I'm interested in all the children that's spending more than 26.3 hours in front of a TV per week. That's my target. So what's the probability for z being greater than 1.94? Alrighty, let's grab our z-chart, okay? And we're going to look for 1.94, and we see here that it's 0.9738. 0.9738. Oh, wait a second. That's not this little thing. This is definitely not 0.9738. This seems to be like too little. Well, of course it is, because 0.9738 gives me everything that is to the left of my z-score. Okay, there is my z-score. So this is 0.9738. This is exactly everything that I do not need. So what do? We're going to take this and we're going to subtract it from 1. And we're going to end up with 0.0262. And that makes sense. It's about 2.5%, and that's about what I would expect it to be. All right? Well, see you in a bit in the next video.